Hi, good morning. Welcome to this session. In the previous session, we have seen the GPIO configuration. In this session, we will see configuring and using interrupts which are passing through Peripheral Interrupt Expansion module. In this case, we will consider timer 0 interrupt as a source. Similarly, there are other interrupt sources like peripheral interrupt sources like ADC, EPWM interrupt source, like kind of thing. In this session, we will focus on the timer 0 interrupt source. Okay, mainly how to configure the peripheral interrupt expansion module for particular interrupt source. That is the today's aim of the session. As an example, we will consider in the interrupt service routine we have two threads. In thread 1 we have to blink the blue LED for every 0.5 seconds. In the thread 2 we have to blink red LED for every 1 second. Okay, for generating interrupt we will use timer 0 as a interrupt source. For thread 2 we will derive the timing interrupt from the thread 1 itself. That means timer 0 interrupts itself. That means here, for example, 0.5 seconds interrupt will come. For every 0.5 seconds this timer 0 will generate the interrupt. Here for thread 2 we want 1 second. For that we will put one counter for every alternative timer interrupts. We will execute thread 2. For every interrupt we will execute thread 1. That is the aim of this today's session. Let's open the technical reference manual. In technical reference manual, go to the CPU timers 012. This is the CPU timers block diagram. Here we have to, during configuration, we have to give we have to load some registers. Okay, it will use a system clock for counting purpose. We will load the period register here, 32-bit period register, and this 32-bit counter will count from this period value to 0. Whenever the counter reaches 0, the timer interrupt will be triggered. These details have been given here. Note that for generating interrupt from other timers, there is for example timer 1 is not passing through the peripheral interrupt expansion module. Therefore you need not to configure while using timer 1 interrupt timer 1 as a interrupt source. Okay, similarly timer 2, the other details have been given here. Okay, let us go to the for example for getting 0.5 seconds for getting interrupt for every 0.5 seconds, what is the value of time period? That calculation I have mentioned here. For example, for every 0.5 seconds we want interrupt. CPU clock frequency we know, default 200 MHz. That means for getting 1 second, for counting for 1 second, we have to count 200 mega counts minus 1 count, because this counter is starting from 0. That's why we are subtracting minus 1. Okay, in this way for 0.5 seconds we have to count this many counts. That hexadecimal equivalent hexadecimal number I have mentioned here. This one we will load into the timer period register. Okay, okay, that's it. That's it. Now we will go to the peripheral interrupt channel mapping. Here we have to identify where is the timer 0 interrupt. Here Here you can see here 1 2 3 up to 12, these are the interrupt groups. Okay, in group 1 our timer 0 interrupt belongs to the in group 1. Okay, group 1 interrupt 7 timer 0. Similarly, for example, you have to generate the you have to use EPWM as a interrupt source. For example, EPWM1 trigger source, trigger zone actually. And if you want to use EPWM as an interrupt source, it belongs to the group 2 interrupt 1. Okay, based on the group 1 has the highest priority, and similarly this number represents the priority. Okay, in this session we will use group 1 interrupt 7. Okay, for doing this we have to know this PIE peripheral interrupt expansion vector table. Vector table has been mentioned here. Here our group 1 interrupt 1.7, group 1 interrupt 7 timer 0 interrupt, the address is 0D4C. Okay, in this address we have to load our ISR address. Okay, these details we will write the code, then you will understand better. Okay, for doing this we have to, here they have provided the steps, sequence of steps. First we have to for this is the block diagram, interrupt propagation path. Here peripheral interrupt expansion, interrupt enable register is there, PIE acknowledgement register, IER, these are global enable registers. Okay, we have to configure these registers such that our interrupt PI interrupt 1.7 will pass through this peripheral interrupt expansion, this module, to the CPU. Okay, now let me open the code, then you will understand better. This code I will share with you. Okay, see, this is the main function. Okay, this GPIO configuration, right now I am using GPIO 31 and 34. This configuration we have covered in the last session, that's why I am not discussing it right now, but I am using because I want to blink the LEDs. Okay, the GPIO configuration we have covered already. Now I am moving into the timer 0 initialization first, and here timer 0 means peripheral interrupt expansion module configuration. Actually it also involves timer registers. Here I have taken the name, it doesn't mean only timer 0, PI peripheral interrupt expansion module configuration actually. Okay, there what is the procedure given here? Enabling interrupts. To enable peripheral interrupt, we have to first, step number 1, disable interrupts globally. This setc intm, this thing we have to do. I have written here. Okay, sorry. Then what is the next step? Enable the PIE by setting ENPIE bit of the PIE control register. This bit we have to enable. To do that, we need PIE control register address. Okay, those address you can find here: system control register, PIE control registers. Here PIE control register offset is 0, base is base addresses, PIE control registers base address 0C E0. These addresses I have shared here. You can note here. Okay, where we have 0C E0, PIE control register. Here what is there? ENPIE bit we have to make 1, bit 0 we have to make 1, enable vector fetching from the EPE block. Okay, for that 0C E0 offset 0. Okay, I am pointing to this address location and I am loading bit 0 as 1 and the remaining bits I am not disturbing. That's why I am using OR operation here. Okay, next we have to, let's proceed to the, what is the next step? Where is that? What is the next step? We have to write the ISR vector for each interrupt to the appropriate location in the PIE vector table. We have to load our ISR address into the PIE vector table. Okay, for this we need to know PIE vector table address. That address where we will find here. Earlier we have seen here interrupt 1.7 0D4C for timer 0 interrupt. Okay, for this 0D4C we have to load our ISR address. Okay, ISR address, this ISR is there, we are blinking the LED, our LED blinking code is here. Okay, this address I am giving here. Okay, for that I am using XAR0 and XAR7 registers. Okay, I am loading this PIE vector table in this address. I am loading ISR address. Okay, in the next, what is the next step? There is the configuring and using interrupts. This step we have completed. Now set the appropriate PIE IER X bit. That means in group 1, in this register group 1 bit we have to enable. Okay, PIE IER, this one, group 1 we have to enable. For that we have to know the what is the address. Okay, for that PIE IER, this one, PIE IER1 interrupt, this is offset to base address is 0C E0. Okay, offset to 0C E2, that is our address. Here we are interrupt 1, this one this is group 1 register interrupt 7. Okay, here you can see interrupt 7. Okay, interrupt 1.7. okay, that one I am doing here 0C E2. I am loading with 7th bit means 40, right? That's why I am loading 40 here. Loading 40 into the 0C E2 address. Okay, what is the next step? Configuring, and next step is set the CPU IER bit for any PIE group containing enabled interrupts. Okay, in the IER, that means this one we have to set, that means we have to keep this switch to 1. Okay, to do that the IER register I am writing 1. Okay, then what is the next step? Then enable the interrupt in peripheral. Okay, to do that, clear C INTM. This instruction has given here. This switch we have to INTM we have to put to the 0. Okay, that one, clear C INTM I am writing here. Global interrupt enable, that one. Okay, what are the next step? Yeah, this one has completed in the PIE module. Later is timer 0, period register and counter register we have to load. For that here CPU timer registers are there. Here period register and counter register. Counter register is 0. We have to load period register. For that we need base address. CPU timer 0, base address is 0C00, 0C00, offset 2. 0C02 is our required address. 0C02. Okay, in that address we have calculated for 0.5 seconds what is the number, hexadecimal number. This is 05F5. Okay, for that this is the MSB, this is the LSB. First we have to load LSB, increment, then MSB. Okay, this is 32-bit register. Then TCR register is there. In TCR register, control register, in the TCR register, sorry, where is that? Yeah, here we have to enable TIE. Okay, CPU interrupt timer has to be enabled. The earlier okay, this TCR register also there, we have to enable that. For that we need, what is the base address? Offset is 4, offset is 4, CPU 0, 0C00, that means 0C04 is our actual address for the TCR control register. Okay, that one I have mentioned here. In 0C04 we are loading where is that control register? Here 14th bit means 40, right? 4000. Okay, that's why here 4000 I am loading. Then this is the end of the peripheral interrupt peripheral interrupt expansion for expansion module configuration for the timer 0 interrupt. Okay, in the that's it. Later this line I have used for counter for creating the software interrupt for thread 2. Okay, in the ISR we have thread 1 and thread 2. In thread 1 we are toggling the blue LED. These addresses we have covered in the earlier session, that's why I am not going to discuss again. Okay, for GPIO, these are actually we are writing into the toggle register. This is toggle register, GPA toggle register. This is toggle GPB toggle register. For GPIO 34 we are loading with 04, and for GPIO 31 we are loading with 8000. Okay, this one we have covered earlier. The thing is, red LED for every ISR interrupt service routine, these two lines will execute. That means blue LED will blink. For blinking red LED there is a counter. Okay, initially we are loading AR7 with 1. Okay, for first time it will decrement to 0, and if decrement to 0, branch if not 0. Okay, this is post decrement. This is 1, right? That's why it won't branch if not 0. That's why it will exit, means it won't blink, toggle the red LED, it will execute. Here one more thing, we have to give acknowledgement for timer 0 interrupt. Acknowledgement means where is that? Yeah, here this acknowledgement is there now. Once interrupt passes to the CPU, this switch will be go up. Okay, that's why after go up, so that no other interrupts from the same group will not reach to the CPU. Okay, that's why after finishing our interrupt service routine, we have to close this switch. For doing that, here PIE acknowledgement register is there. In that we have to, let's see where is the PIE acknowledgement register. Here PIE acknowledgement register. Here for group 1 we have to acknowledge bit 0. Okay, that's why what is the address? Offset 1 base is 0C E0. Okay, 0C E1 is the our address, 0C E1. In that I am loading 1 for setting the group 1 acknowledgement. Okay, so that if next interrupt has been generated, it will pass to the CPU. Okay, this one must. Okay, similarly for other interrupt sources, corresponding groups you have to acknowledge after completing our ISR. Okay, for alternative, for if branch if not 0, for the second time this code also, this condition will fail. That's why next instruction this code also will execute. Again I am setting my counter for generating software interrupt. Okay, this is that's it. Okay, now I have connected the processor. Okay, now no blinking. I am loading the program to the processor. Okay, little my PC little slow, that's why it is taking time. Hold a minute. Okay, now I am running the code. Now what to happen? Blue LED blinks fast, red LED for every 0.5 second blue LED will toggle, for every 1 second red LED will toggle. Okay, you can observe here. Okay, all these registers and addresses I have shown here. Okay, you can go through yourself through the code. For any other interrupt sources, interrupt generating sources, the only thing will be changed is here what is the group, what is the interrupt number. Okay, this one. Okay, for that respective numbers will be changed here. Okay, that's it for the today's session. The speed of the LED you can verify using your timer. Okay, thank you. We will see in the next, we will meet in the next session. Thank you.